Ever wondered how humans managed to reach the edge of space even before the first man landed on the moon? It's a question that stirs the imagination, and the answer lies in the brilliant engineering of the X-15. The X-15 was not just any ordinary aircraft. It was a hypersonic rocket-powered aircraft, a masterpiece of the mid-20th century, a time when the world was in the throes of the Cold War. This was an era marked by a fierce rivalry between the superpowers of the world, each vying for dominance not just on Earth, but beyond its boundaries. The X-15 was a product of this competition, a symbol of the intense drive for technological advancement and innovation that defined the times. The X-15 was introduced in the late 1950s, a time when space was still a mystery, a realm untouched by human exploration. It was designed and built for one purpose: to go faster and higher than any aircraft before it, to push the boundaries of what was deemed possible. And it did just that. It was a vehicle that took humans to the edge of space, reaching altitudes that had once seemed unreachable, soaring to speeds that were once thought to be unattainable. The X-15 played a pivotal role in the history of space exploration. It was an engineering marvel that paved the way for future space missions, a stepping stone towards the moon landing, and a precursor to the space shuttles that would come later. But beyond its historical significance, the X-15 was a testament to the power of engineering, a demonstration of the incredible feats that can be achieved when human ingenuity is paired with technological prowess. It was a machine that challenged the known limits, that dared to venture into the unknown, that defied the laws that governed flight and space. Indeed, the X-15 was a marvel of engineering, a testament to the ingenuity of the human mind. It was a symbol of the unseen power of engineering, a reminder that with the right tools and the right minds, the sky is not the limit, but just the beginning. The conception and creation of the X-15 was no small feat. Picture this: the dawn of the 60s, a time when engineers were pushing the boundaries of what was possible, and at the heart of this revolution was the X-15. The initial design phase of the X-15 was fraught with challenges. Engineers were tasked with creating a machine that could withstand the harshest conditions known to man, the vacuum of space. This was uncharted territory, and the margin for error was infinitesimally small. But the engineers at North American Aviation were undeterred. Their solution? An innovative approach to design that put aerodynamics at the forefront. The X-15 was designed to be sleek, capable of slicing through the atmosphere like a hot knife through butter. Its elongated fuselage and stubby wings, reminiscent of a dart, were not just for show. They were meticulously crafted to minimize drag and maximize speed. The design was so effective that it allowed the X-15 to reach speeds in excess of 6 times the speed of sound. But speed was just one part of the equation. The X-15 also needed to withstand the extreme conditions of space. This was where the use of innovative materials came into play. The fuselage was crafted from a nickel-chromium alloy, known as Inconel X, capable of withstanding temperatures of up to 2,000 degrees Fahrenheit. This was groundbreaking at the time and set a precedent for future space vehicles. The engineers also had to grapple with the issue of re-entry. How could they ensure the X-15 could return safely to Earth's atmosphere? The solution was a wedge-shaped tail, which generated enough lift to stabilize the aircraft during re-entry, yet was robust enough to endure the intense heat and pressure. The birth of the X-15 was a turning point in aviation and space exploration, setting new standards in engineering. It was a testament to human ingenuity, a beacon of what we could achieve when we dared to dream. It was, in every sense of the word, the birth of a beast. And its legacy? Well, that's a story for another time. The heart of the X-15, its engine, was a marvel of engineering. A marvel that pushed the boundaries of what was considered possible, an intricate piece of machinery that rocketed the X-15 into the annals of aviation history. The engine, a Reaction Motors XLR 99 RM2, was the first of its kind to be throttleable, allowing the pilot to adjust the thrust levels while in flight. Imagine that, modulating the power of a rocket engine while soaring through the sky. It was a feature that added a level of control and flexibility unheard of in the realm of rocket engines at the time. This powerhouse was capable of delivering a staggering 57,000 pounds of thrust. a force so immense it could catapult the X-15 to a speed of over 4,000 miles per hour. That's more than 5 times the speed of sound. And it didn't stop there. The engine could propel the aircraft to altitudes of over 67 miles, high enough to qualify the pilots for astronaut status. What made the X-15's engine even more remarkable was its use of a unique fuel mixture, a combination of anhydrous ammonia and liquid oxygen. This potent concoction was responsible for the X-15's record-shattering performances, allowing the aircraft to reach altitudes and speeds that were once thought to be the exclusive domain of space-bound rockets. But it wasn't just about power and speed. The engine's design was a feat of engineering ingenuity. Its regenerative cooling system, which used the fuel to cool the engine before combustion, was a pioneering concept that is still used in rocket engines today. The X-15's engine was a testament to the awe-inspiring power of engineering, a symbol of mankind's relentless pursuit of knowledge and exploration. It was more than just a motor. It was a technological titan, a beacon of innovation that illuminated the path for future advancements in aviation. The X-15's engine was a powerhouse, propelling it to new heights and speeds never before reached by manned aircraft. The X-15 did not just fly, it soared to the edge of space. Picture this, a sleek black airframe powered by a mighty rocket engine cutting through the atmosphere, faster than any plane before it, higher than any human had dared to go. The X-15 was not just a marvel of aerospace engineering, it was a vessel of discovery, a chariot that carried us to the very edge of the known world. The X-15's missions were not mere flights. They were voyages into the unknown. Over the course of nearly 200 flights, it explored the harsh, unforgiving environment of the upper atmosphere and the fringes of space. It pushed the envelope, setting records for altitude and speed that still stand to this day. At its peak, the X-15 reached heights of over 67 miles and speeds over 4,500 miles per hour. That's more than 6 times the speed of sound. But these achievements were not the product of chance or luck. They were the culmination of years of meticulous engineering and painstaking research. The X-15 was a triumph of human ingenuity, a testament to our ability to transform dreams into reality. Its aerodynamic design, its revolutionary materials, its cutting-edge control systems. Every aspect of the X-15 was engineered for the extreme conditions it would face. Its wings, thin and flat, were designed for the thin air of the upper atmosphere. Its skin, made of a special alloy, could withstand the intense heat of re-entry. Its reaction control system, a first in a manned aircraft, allowed it to maneuver in the vacuum of space. These technological marvels allowed the X-15 to perform feats that were once thought impossible. It could climb higher, fly faster, and endure more than any aircraft before it. It proved that we could build machines capable of exploring the very edge of space, that we could stand on the brink of the unknown and not flinch. The X-15 pushed the boundaries of what was thought possible, forever changing our understanding of flight and space exploration. The X-15's engineering was revolutionary, and its legacy continues to inspire. As we delve into the legacy of this remarkable machine, it becomes clear that the X-15 was not just a marvel of its time, but a pioneer that paved the way for future innovations in aerospace technology. The X-15 was a trailblazer, pushing the envelope of what was possible in the realm of high-speed flight. Its cutting-edge design and engineering principles have been instrumental in shaping subsequent aircraft and spacecraft designs. The X-15's unique blend of aerodynamics, propulsion, and materials science was a game-changer. It showcased how to withstand the incredible heat and pressure of hypersonic flight, a lesson that continues to inform the design of modern-day re-entry vehicles and spacecraft. Moreover, the X-15 was not just a technological marvel, it was a wellspring of invaluable data. The multitude of experiments conducted during its missions have provided insights into aerodynamics, astronautics, and the very nature of the space environment. This wealth of knowledge has been integral to the development of technologies that enable human spaceflight, satellite deployment, and interplanetary missions. The X-15 also set a precedent for rigorous testing and safety procedures in aerospace engineering. The trials and tribulations faced during its development process underscored the importance of meticulous testing and stringent safety measures. These lessons have been carried forward, influencing the protocols and standards in the aerospace industry today. But perhaps the most profound impact of the X-15 was its role in inspiring a generation of engineers, astronauts, and dreamers. It demonstrated that the seemingly impossible could be achieved with ingenuity, determination, and a healthy respect for the laws of physics. The X-15's legacy continues to fuel the dreams of those aspiring to reach beyond the confines of our planet. The X-15, a true testament to the power of engineering, has left an indelible mark on the world of aerospace technology. Its influence resonates in the hum of jet engines, the roar of rocket launches, and the silent glide of spacecraft exploring the cosmic frontier. The X-15's legacy is not just in the past, but lives on, shaping the future of aerospace exploration.